Alright, this is John Black. I'll tell you right from the get-go, this is going to be a crappy video. But I'm basically putting up so people know what I'm going to do, what I want my channel to be about. You know what I mean? I want this to be about a learning thing, not about Walter White, some stupid crap. Williams are talking about meth. This is not about that. This is about learning. I wanted to go over a few experiments I'd like to do. One of them is toluene, benzaldehyde, benzoic acid, benzene. Those are all building blocks to bigger molecules. One example here is toluene, methylbenzene I have down here. As you can see up on here, I'll point to it right there. What I like to do is you can get some chlorine, right? UV, and you can make these three thingies here. See how I got one chlorine on there, and then right below there I got two chlorines and I got three chlorines. It depends on how much chlorine you put in there. You know what I mean? If you put a 1 mole equivalent, you're going to get the first thing, 2 moles, the second thing, and so on. Now, when you do that, you're going to UV, you're going to make all three of these a little bit. You know what I'm saying? You're never going to have a pure, ultra pure product doing that. So here's another method, right? You can hydrolyze all of these, all three of these chlorines off. If you hydrolyze the first chlorine off, you turn it into an alcohol. The next two, you'll turn those two, each one would be an alcohol, but two alcohols on the same carbon is a carbonyl. So when you have the two on here, you hydrolyze this off into a water, this off into water, and two waters equal that. You got three of them, you're going to do the same thing. You're going to get a water, those two waters are going to turn into a carbonyl, and then that last carbon, or last chlorine, will be turned into a hydroxyl. And that's how you get your benzoic acid. Now, how am I going to get that pure? I want this. I want it to be pure. So, I could hydrolyze it, like I say, here, and a little bit of impurities that I have that are from the dichlorine, I can get rid of that, see, because once I hydrolyze it, it'll be benzaldehyde. I can get rid of that by putting in some bisulfite, and it'll form an adduct. I'll get rid of that. So if I wanted to make benzaldehyde this way, I could do it. I could put in two chlorines, and then when I get done, I can have a really pure benzaldehyde because I would purify it by isolating it with bisulfite. The last one is the three chlorines. That's the best way to go because you can't overchlorinate. You're going to get all three on there. You'll be stuck with it. That's good, though, if you're going for benzoic acid. Anyways, like I was saying, you'll never get this first one pure because it's always going to add a couple more on there. What you could do, though, is get rid of this, right? You hydrolyze it all. What you want is an alcohol, right? The second one, the benzaldehyde, I told you get rid of that because you can make an adduct with the bisulfite. This is going to turn into the salt form of that, so it's going to be insoluble in water. This is not. This is a solid, so it'll be easy to get rid of this and get rid of this and have pure benzyl alcohol. And then you can go back down to that bottom there, see? And you can add your chlorine on. That way you know you're only adding one chlorine on. Not, you know what I mean? Because UV for this right here, that right there is crazy, man. Radicals like to just bounce all over the place. You're going to add no matter what. But on that bottom one, you'll have nice, pure, only one chlorine added onto there, not two or three. That's one of my main things I'd like to do there. I don't think anyone's ever done them on there. If they have, whatever. I'm trying to not do repeats. You know what I'm saying? Some stuff here. I want to make some halohydrins, epoxides, hydrides. Nobody doing any hydrides on here. I got to at least do lithium hydride or sodium hydride, some of the easier hydrides. Phosphorus, and I'm not talking from matches. I'm talking the way you originally do it with the sand and the carbon, and you do it kind of like a replacement thing, you know what I mean? Kind of like a thermite thing, but with sand, carbon, and phosphate. And then you get your phosphorus out. Nitrites, sulfites. I don't see anyone doing those. Phosphoric acid. See a lot of acids made, not that one. Indols and purines. I really want to get into that. I'm doing my sugars right now, or rather my biochemistry, and I want to do a lot of stuff with sugars and that kind of thing. Tosyl chloride. I don't see anyone doing that either. That was a major thing on getting rid of alcohols nicely, and I don't see anyone doing that. Thionyl chloride, malonic ester synthesis of an R substituted acetic acid, acetoacetic acid, where you make an R substituted acetone ketone, beta hydroxycarbonyls, alpha beta unsaturated carbonyls. I want to do that. Claisen condensation, Hell's Vollard Zelinsky, tetrachloromethane. You know, people, I want to do that UV. UV, I said
they use sodium hydroxide or they use calcium oxide. It's called a soda-lime decarboxylation. I don't know why they don't use both. I'm curious though. I mean, maybe they're probably, I know they know, but they're probably using one or the other because they figure it's easier to do and it's for people. You know what I mean? It's for entertainment. But I'm curious as what the difference makes. I am going to have a video on how to make calcium oxide and benzene, even though it's been done a million times, but no one's done it with both of those. So basically what happens is the sodium hydroxide makes the salt form of the benzoic acid. The heat is what drives it off. I don't even think you have to have anything in there. You can basically just heat up benzoic acid and it should turn into benzene. But the calcium oxide helps soak up the carbon dioxide you're heating off. You know, you're decarboxylating, and that way it'll get rid of that instead of trying to connect back onto the benzoic acid. Anyways, that's one thing. Sodium metal. I don't see anyone giving a good way to make sodium metal. They're all terrible methods. I mean, I can't find any better ones, but I'm going to try. Esters. Trying to make esters into alcohols. I'd like to do that. They say it's hard, but I think you can do it with hydrogen and some chromite as a catalyst. I think you can do it. I don't know, though. I guess we'll have to wait and see. The other one is a blank reduction. It's where you take an ester and some sodium metal and some alcohol, as you can see, you know, and you heat it up, and somehow it comes out where you get two alcohols. It breaks down to benzyl alcohol, that particular example, and well, whatever the R is, it'll turn out into an alcohol too. Another thing is everyone says this is impossible. Hold on here, I got something on the screen here. Hold on. What the heck? All right, anyways, as you can see now, this next one, where I got the three right there, those are xylenes, okay? And as you can see, the methyl group is in different position. There's three kinds of xylenes: ortho, para, and meta. The only one that's really good though is the ortho. You know what I'm saying? Where they're right next to each other. Because when you make an anhydride, it's really easy first, and then you can make that. And with that, you can make primary amines. I mean, that's one of the ways you're supposed to do it. That's another thing. I want to make some primary amines, not that formaldehyde crap, ammonium chloride stuff. I want to make it from, like I said, the phthalimide. You know what I mean? I turn that xylene into phthalic acid, phthalic anhydride, and phthalic amide, and I would make my primary amine from that. Anyways, another way is with some kind of metal and acid, and you just heat up a nitro group, you know, like nitromethane or ethane. You heat it up. I don't know if it'll work. We'll see though. Hydrogenation. I don't see anyone doing any hydrogenation videos. So I want to definitely do that. I don't know if you can see it. Let me see here. See down there at the bottom how it says THF. Now what that is that's a cyclic form of diethyl ether. It's basically diethyl ether where it got put, like I said, into a ring there. There's two ways to make it, at least two ways I know of. One is to have like that next molecule there, a bromine on one end and an OH on the other end, and you will make an epoxide, or you will make a ring with an SN reaction. And I don't know, this other way I find it might be easier. Let's see here. Alright, see there how you got xylose, that's a sugar. You can buy that online, or you know what, you can even use corn cobs. Slice up the corn cobs, throw them in a blender or whatever. Throw in some sulfuric acid or whatever, and you'll make furfural, which is this right here. You can easily, I hope, this is all guesswork until I do it. I'm hoping I can decarboxylate that really easy and take it down to furan, which is one of my target molecules, furan. And then the second one is I can hydrogenate that to make THF. All right. Another thing,